So, for example, suppose that g is equal to 2x to the power 3. What is the derivative in this case? For 1 point of extra credit, using the power rule.
It is 6x, Professor.
It sounds good, but I did not hear the entire answer. Go ahead. Well, let's see. In this case, A is 2, and then B is equal to 3 in this case. And then finally, S now has the power of 3 minus 1 or 2. So there is our derivative. One more puzzle for you for 1 point of extra credit. What is the derivative now when g is equal to 2x? Well, let's see. In this case, A, the constant coefficient is 2 times x to the power of 1 minus 1, or 2 times x to the power of 0. But what is the value of x to the power of 0?
1.
Just equal to 1, is it not? So the power rule is very flexible and interesting to use. Now, let's apply the power rule to the profits function for Emirates Airline. So if you would, just take a couple of minutes to jot down your answer to that question for 1 point of extra credit. 2 minutes, and then we will come back together and solve the problem as a class.
Professor, is the answer is 40?
So your calculation is if Q is equal to 40, then we would be maximizing profits in this case. Okay, let's see. We know that we need to set aside the first order condition. In this case, that is the derivative of profits with respect to price Q is equal to 0. So let's see, in this case, the derivative of profits with respect to Q is what? -40
minus 2Q.
for the power rule 2Q equal to 0. So it appears that Q star in this case is equal to 20. That is, we have that manipulation that 40 equals 2Q could be added to the both sides of the equation. And then dividing 40 by 2 gives us 20. And there's our solution to the problem. So I think that's good for 1 point of extra credit for the class. Okay, good. So we've made progress. Usually, when economists are examining profits, they think of it as the difference between revenues and costs. So, for example, if revenues are 60 million and costs or 40 million, then profits are the difference. That is, revenue minus cost gives us 20. So the question now is how to determine profits for various values of revenue and cost. And in general, how would we characterize the point of output that will maximize profits? But when we have revenue and cost functions, well, let's see. Let's begin with an intuitive approach. So this downward sloping function is marginal revenue. That is the revenue of one more flight from Amir's airline. So in this class, when we are talking about marginal anything, marginal is just a rather technical term that really just means additional. One more flight. And now let's add marginal cost. The cost of one more flight. Okay, so to first take a look at flight number 10 for the airline. And the revenue of that flight is, shall we say, $60 million. But the cost of providing that flight is only $10 million. Then for flight number 10, Amir is adding $50 million to his overall profits. Okay, good. Now for 1 point of extra credit, suppose now let me take a look at flight number 11. Right there. For that flight, the 11th flight, revenues are 59. And cost of that flight is 11. So on the 11th flight, how much money is Amir adding to his profits earned only on that flight? Let me see. Amir's revenues on that flight are $59 million. And his cost, operating costs, paying the pilot, the flight attendant and all the rest, his costs are 11 million. So overall, he is adding $38 million to his overall profits. So the point is that as long as marginal revenue is at least as high as marginal cost, Amir will not lose money by adding each additional flight. As long as marginal revenue is greater than marginal cost. So he is maximizing profits right here at Q star because he has already offered any flight that has a net profit, the 10th, the 11th, the 50th, whatever. As long as marginal revenue is covering the additional cost of that flight, he can add to his overall profits. So the rule is they maximize profits at the level of output the marginal revenue is equal to marginal cost. Okay, so far. Actually, we could have arrived at the result by using a bit of calculus. So I will denote profits as Z in this case, and Q is the number of flights. R for revenue, and C for cost. Okay, so if we are differentiating profits with respect to Q in this case, we have that marginal revenue minus marginal cost is the first order condition. And therefore must equal zero. So notice that marginal revenue is just a derivative of total revenue with respect to output, and the same thing for cost. So this first order condition suggests that marginal revenue is equal to marginal cost at the level of output that will maximize profits. So once again, we get the rule that we should equate marginal revenue to marginal cost to maximize profits. Okay, so far. Any questions up to this point?
No questions, thank you.
Okay, thank you. So there's a puzzle for you to try in the next 5 minutes. I've given you a total cost function and then an inverse demand function that is priced as a function of output. Again, for Amir's airline. So can you find the number of flights and the price of each flight that will maximize profits in this case? And then finally calculate the profits. Good for 3 points of extra credit. So let me know what your solution is. Don't worry about whether the solution is wrong. There's no penalty, only a bonus in this case. Okay, 5 minutes, and then we will come back together as a class to solve the problem. Okay, let's see how you did with the problem.
Professor,
Yes,
quantity is 10.
say again.
Quantity is 10, isn't it?
Well, let's see. That sounds reasonable to me, but let's put it on the whiteboard and see. So let's see, we have a total cost function of 50 plus q squared. So what is our marginal cost in this case?
Two Q.
Good, 2q. That does not involve the constant, because by definition, the change in the constant is obviously zero. Now, all that we need is marginal revenue. And then we can equate them. However, the only function that I gave you is the inverse price function. So how can we get the revenue function in this case?
We multiply quantity by demand and we get
That's
revenue.
good. Good. So revenue, as always, is the amount of money that we make by selling airline tickets, or the price of times quantity. And as you say, this suggests that revenue is equal to the inverse demand function, 40 minus Q times Q. Or to spell it out, we have 40Q minus Q squared. So now most of revenue turns out to be rather easy to divide, as you suggest. As the derivative of total revenue relative to output. Or 40 minus 2Q. And now we can take a look at Nervi's solution. We know that the maximized profit in this case, where marginal revenue is equal to marginal cost. So marginal cost is 2Q. Marginal revenue is 40 minus 2Q. So let's add 2Q to both sides, equal to 40. And there is Nervi's solution. A mere will launch 10 flights per day to maximize his profits. So now, why don't you take a minute to calculate the profits in this case for the monopoly? 2 minutes, and then we will reconvene as a class. Okay, good. But let's see how you did. Let's begin this time with total cost. And then we will divide total revenue and finally subtract total cost from total revenue for profit. There is our cost function. Now, remembering that Q is 10, total cost is easy to calculate. $50 plus 10 times 10 is 100. Okay, so now what about total revenue?
It will be 400 minus 100, so it will be 300.
Okay, let's try that. Again, that sounds like a good solution. Revenue in this case is 40Q of minus Q squared. And Q again is 10. So revenues are 400 minus 100. Or as the right says, 300. So what are total profits in this case?
It is
150.
Good. Yes, total revenue minus total cost. And Newberry has just told us, and we verified that total revenue is 300. And then total cost 150. Or total profit of 150 in this case. Questions about that solution? So the main thing for today that I hope you will bring away from our discussion is to look in maximizing profits, look for the level of output. The marginal revenue equals marginal cost.